Hey everyone, I'm Nick from Coffee Before Arch, and in this episode of viewer suggestions, we're going to be talking about CMake. Now, when we've got kind of cross-platform stuff and we want to automate the actual generation of things like make files, a lot of times we'll use something like CMake. So what CMake really allows us to do is take a look at what system we're running on and then change how our project is built based upon what it finds in our system, right? And it can be a really good way of automating the build process. And so we'll go ahead and look at this at a fairly simple example. It's taken and slightly modified from the CMake.org CMake tutorial, but we're going to explain things in a bit more detail than is on the actual site itself. Right, so we're going to answer a couple questions here as to what CMake can do and why it's useful. Now let's consider a scenario, right? So maybe we'll have things that we want to pass into a or let's say that we want to avoid, say, editing a whole bunch of source code every time we do something like change a version number of our software or release number of our software, right? So it'd be nice if we had a way to more easily or programmatically do this, right? And sometimes that release number will change how something gets compiled, right? Or what happens in the code depends on what release it is. So we want some way of easily doing that without having to dig around in source code. Another thing we also want to do is we want a nice way of, say, conditionally, compiling our code based upon what's available in the system, right? So those are the two things we're really going to look at today. So not modifying source code and doing that more externally, and then B, conditionally doing things in our code based upon what we have available in our system. So let's start off with our example, right? So that's going to be in this powers.cpp. So we have a pretty simple file right here that we use as an example, which is it just takes a base to an exponent, right? But there's a lot of things in here that we'll be using a lot of things from CMake. So it all starts with the CMake Lists file, right? So we're going to need a CMake Lists file to start things off. And we'll start out by doing some very basic things, right? So we'll set a minimum required version of CMake. We also set a project name. So this will set this project name variable. The next thing we want to do is answer the question of how do we, say, insert things into our code without having to, say, directly modify source code every single time. So an easy example of this is something like major and minor release numbers, right? So if we want release 1.1, 1.2, 2.7, we don't necessarily want to have to dig into source code and change that every single time. So what we can do instead is we can have this defined externally, right? And then another thing that we can have as well is we can have options, right? And these options, say use my math, we can use these options to determine what we actually do inside of our code, right? So we can have compiler directives telling us what is defined and what is not defined. So in this case, we use this configure file, and what this configure file will do is it will take some input file. So in this case, it will be powersconfig.h.in. This project source dir and project binary dir are automatically defined. So in this case, it will just be our root directory. And relative to the root directory, we'll have it just in the same directory as everything else, this .h.in. So let's go ahead and open up that file. So it'll be powersconfig.h.in. And we'll have three things in here. So we'll have this define powers version major, and then this at powers version major, and also powers version minor. And what will happen when we do this configure file is that we'll look at these things we've defined up here, so powers version major and minor, and it will use these values of 1 and 0 and replace where these at signs are in the variable name. It will replace these with 1 and 0. Likewise, we have this CMake define use math, and then depending on how in this case use my math will be set as on, right? So like a Boolean value. So CMake define will use a comparison using just if, right? And so it'll do if use my math, and it will do something or set some value based on that, right? So in this case, it will change CMake define use my math to just define use my math, right? And so it will take this file and make those changes and then copy it into powersconfig.h, just a header file, right? So if we actually look in our code, this powers.cpp, we see we've got this header generated by CMake, and we'll just include it in our file. Now we're automatically making changes to this header by just calling CMake, right? So instead of having to directly modify source code, it's happening automatically. The next thing that we'll talk about is this conditional compilation, right? So if we go back in here to CMake Lists.txt, we see we've got this if use mymath, right? So we've defined this use mymath already, so we know it's going to be true because it's set as on already. So what we're going to go ahead and do is we're going to use a different version of the power function. So the C standard library has an implementation that we can include CMath and use, but say we want to use our own, right? And this is more applicable when we've got, say, our own custom function that we want to use. Or maybe we want to choose between different libraries that implement highly optimized functions. So in this case, we'll include a directory, right? So in this case, we'll include project source dir, right? So we said that's automatically defined, and then we'll include local functions. Now local functions is just another directory we have in here, and it has three things in it. It has its own CMake list, so we're going to be making exponent.cpp as well, so it's going to need a CMake lists.txt, and then we have the actual source code in the cpp file, and we have a function prototype in the header file. So if we open up exponent.cpp, we've got just a simple myPower function, right? And it will only work for a limited range of cases. So if the exponent's either 0, or if the exponent is say a positive number, so it won't work if we throw in a negative number, and it only works with integers as well. But going back to our CMake lists, right? So we'll go ahead and include this directory because we need to be able to find header files, right? So header files might not be in the directory as the source file. So what we'll do is we'll use include directories to automatically generate, say, that -i that we use in, say, a make file to include a specific directory. We can get that automatically by just saying include directories. We've done that as well right here to include the directories for this powersconfig.h file. Now the next thing we need to do is we need to say, well, I need you to build that library that I'm going to link against. And we do that with add subdirectory. So that will go ahead and say, we'll add it so that myPower function will be built, right? And that's why we have this, if we go to local functions again, that's why it has its own CMake list.txt, because exponent needs to be built. Now in this case, we're going to build it as a library. Now to build it as a library, all we need to do is say add library. Now in this case, it will just be built right as exponent, right? So it'll be lib exponent.a, and the input file to build this is just exponent.cpp. So no other requirements there. So this is probably about as simple of a CMake list file as you'll get, right? So then we go back to CMake list.txt. So again, we include this directory. That way we get access to the function prototype that we use here in exponent.h, right? So we're including that inside of our power function, but it's in a different directory. So we need to include the directory inside of our CMake lists. And this is, again, conditionally included based upon the definition of use mymath. So if we don't have use mymath included, we don't even care about that other library. We don't even build that other library. We only build it if that option up here, use mymath, is set, right? And then we use set again, right? In this case, in a different context, to set this variable extra libs, right? And we want to maybe include multiple different libraries or link against multiple different libraries. Right, so extra libs is just a name that we give. It doesn't have a special, it's not a special name. But the reason why we do this, this version of set is because we want to potentially concatenate and add multiple different libraries to include, right? So in these other versions, we're basically just overwriting values, right? Or we're just, they're not going to change, so we're not concatenating things. But with libraries, right, we might have multiple libraries that we're going to include, right? So we leave this very generic, and in this case, extra libs will either be, just exponent, and exponent, just as a reminder, is just going to be, if we go to CMake List in the other directory, that's the name of the library that we're generating, right? So it's either going to be exponent, or if useMath is not defined, it'll be nothing, right? It'll just be empty. So the final things we do, right, in terms of this basic example, is we go ahead and add the executable. Now this will go ahead and build, or it will build the executable powers, right? And it will build it from powers.cpp, right? So it's saying now we want to build an executable from this source, right? But, again, we want to link against that exponent library that we made, or nothing if we didn't make that exponent library. So this will either be empty and we won't link against anything, or we'll link against the libexponent.a file. Right, and so we'll use target link libraries to go ahead and link those together. Right, so that's going to go ahead and do it for this. It seems like very complicated, and it is very complicated for something as simple as this. But as you can see, there's a lot of very useful features once we start having more complex projects that are useful. So let's kind of give a rundown of everything we've gone over. Right, so the first thing we looked at was, how do we say automatically include or generate header files? We want to include options into our source code. And we do that by setting variables, using options, and then calling configure file to generate, say a header file, right? In this case, ours is called powersconfig.h. We can include directories using the, rather aptly named include directories command. We can add, other subdirectories to start building make files for other things using add subdirectory. And then we can also, set other variables that we want to use later on using set. Then we can, add, the generation of executables using add executable. And we can, handle any linking we need to do using target link libraries. And we can also, inside of local functions, CMake Lists, we can also add libraries to be built through add library, right? So that's really the basics of this. So if we go ahead and do, so to run this, right, in order to generate these make files, we'll just call CMake./ right? That's giving the directory. So we see that it does a number of things. So it'll check the compiler, right? And it'll check for the, check that it's working. Then it'll also do things like check the ABI info, check the features, etc. Now, in more complex setups, right, you'll actually do things depending on what features are supported. So in very complex projects or projects meant to be run, for multiple different configurations. So now you see we've got a number of different things now in our directory. So we've got the CMakeCache.txt. We've got a header file that was generated, so not just a .h.in. And if we go to powersconfig.h, we see that powers version major is now 1, powers version minor is now 0, and that CMake define has turned into just a normal compiler define. Right. So then we have our CMakeCache.txt. Now that's so that when CMake can take a long time to run. Once we run it, if we have a very, very big project that's very complex, right? So CMakeCache.txt is a way of speeding this up if you're running it multiple times. So we go to CMakeCache.txt. We've got a number of things in here, including, you can see it caches, our own exponent function, right? So we see that in that option, right? So it goes ahead and automatically adds this comment. And we see that it's set to on, right? Because we set it to on in our code. We also see that, here's our powers binary dir and source dir. So we saw those inside of our CMake list as well, right? And we see that that's just our directory that we're working in, right? So the CMake example directory, right? So if I exit out of here and I just do pwd, we see it's the same directory, right? And you see that this was also generated, likewise for our local functions. We see it has its own, CMake files and make file, right? So let's actually build it, right? So now that we've got everything set up, right? So as a reminder, here's our source code. It's powers.cpp. So in this case, it will go ahead and include exponent.h. It includes, our generated file from CMake with those defines in it. It'll also, down here, we'll end up using this myPower function because we've defined use myMath, right? And then at the very end, it'll print out our result. Right, so we can just call make, and we see that it builds our project, right? It links this lib exponent.a, right, and it links that up with our powers function that we've compiled. So we get our powers function here, right? So that's our executable, and then if we go into our local functions, right, we see that we've got this lib exponent.a as well. So that's our static library, right? And then we can go ahead and just run this, right? We can run powers and we get our expected result, right? So we get our major version or minor version, and then 4 cubed is just going to be 64. So 16 times 4 is 64. Right, so that's really the basics of working with CMake. In other videos, we might go into other things such as automating testing as well, and maybe some more complex features of CMake. But this is really the basics of getting into CMake and understanding how things work. So as always, all this code, you can feel free to take a look at this and download it yourself. You can go to github.com/coffeebeforearch, where we've got repositories for things like the C++ course, CUDA programming, Python programming, etc. So in this case, this is actually in our miscellaneous code directory. So if you go ahead and go to miscellaneous code, then under CMake example, right, so we have this entire example. So feel free to download this, play around with it, check it out. Of course, just like this was a suggestion from a viewer, feel free to let me know if there's any particular topics that you'd like covered, and I'd be happy to do it. As always though, I'm Nick, and I hope you have a nice day.